Hello everyone, welcome to the session. So now in this particular video, we will be talking about the assumptions that we have in linear regression. So I hope that until so far, whatever concepts I have covered up with respect to the mathematical intuition that we have in linear regression is pretty much clear to everyone. Now, it's not like that for any regression problem and for any kind of a data set, you will directly go with the linear regression. Linear regression comes with its own assumptions that I really want everyone should be aware of. And in an interviews also, many people can ask from you that, can you tell me what are the assumptions which linear regression usually takes up? So let's get started and we'll try to understand what are the assumptions that we have in a linear regression algorithm. So the very first assumption that we have is, by the name itself, it suggests linearity. Linearity. So what is the meaning of linearity? You know that we do have a lot many independent features in our data set, which you can take it as x1, x2, x3 until the value of xn, depending upon how many number of features that we have. Corresponding to every feature, we will be having something called as a target value, because we are anyhow dealing with the supervised machine learning techniques, right? So now what I'm saying is that these independent features are linear dependent on the dependent features. What is the meaning of that? That this x and the value of y completely, they follow a linear function. They are linear in nature. What is the meaning of linearity? Just now in the last session, we have discussed that we want to create a straight line, right? Where let's say we will be having a input value as, let's say, the weight, right? And or maybe the input value is the height. Okay, and what I want to give as a prediction is the weight corresponding to every particular height that we have in a given data set. So I can say that this is the value of x and this is what I want to predict as a value of y. So you know that as a person's height increase, the weight also increase. They follow a linear I would say line, linear proportion, directly proportional to each other, or they may be inversely proportional to each other. At any point of time, they follow a linear line. Can I say? They will follow a line which follows y is equals to mx plus c. Can we say this? I hope everyone knows this particular part. We already have discussed in our last session. And that's where whenever we are saying that linear regression algorithm is training, we want to find a optimal value of what? Optimal value of this m and the value of c. We want to find the optimal values of m and c. That is what we have understood in the last sessions. So when someone is saying that we are training our model with the help of a linear regression algorithm, we know now that that person tries to say that I'm trying to get that optimal value of m and c in order to create something called as a best fit line. In order to create something called as a best fit line. Yes or no? I hope everyone is aware about this particular fact. So basically, your value of y and the value of x will be linear in nature. That's the very first property which we should know, or which is the assumption of our linear regression algorithm. The second important property is the independence. Independence. What is the meaning of that? The simple meaning is that whatever be the input features you have, whatever be the value of x1, x2, x3 until the value of xn you have, right? All these particular input features are independent of each other. They should not follow any particular pattern. They should be independent of each other. They should be independent of each other. Always make sure that they should not follow any pattern. It's not like that if the value of x2 is increasing, the value of x3 is also increasing. They should not be having a dependency on each other. Okay? The third important property is the normality. Normality, which linear regression algorithm assumes. What is the meaning of normality? Always remember that I hope that in statistics you are already aware about something called as a normal distribution, or this is something which we call as a Gaussian distribution as well. This is one and the same thing. Many people are confused in this point also. Normal distribution or Gaussian distribution, which is nothing but is a bell-shaped curve. I hope you all are aware about this thing, like this. Bell-shaped curve. Right? Where in the middle of the curve, if I'll just try to create it here, in the middle of the curve, the value of the mean, the value of the median, and the value of the mode which are the measures of dispersions that we have, is almost equal to each other. They must be equal if we're talking about normal or Gaussian distribution. So when I'm saying normality, we in the last session have studied about something called as the residuals. What is the meaning of residuals? The gap, the difference between the value of y and the value of y cap. Now that gap or the loss function we can measure by the value of MAE or the value of MSE depending upon how many outliers we have in our data set. So that kind of residuals always follow something called as a normality kind of a distribution. Okay? They always follow a normality kind of a distribution. Means if you will try to create a graph of that error value that you will be able to get at each and every iteration, they will follow a normal distribution. That's the property number 3. Assumption number 3, again you can say. The last important assumption is something called as a homoscedasticity. Homoscedasticity. This property says that if you will try to calculate the variance of the residuals, they should be constant. Variance of the residuals should be constant. Okay. Now, what is variance? It's the dispersion from the mean, how much values are varied with each other. So again, if you will try to create a graph or the distribution of that particular error terms of the residuals that we have, they should be constant. It's not that there will be a major change in between and then change will be varying with each other with respect to the variance part. So this is the property which we call as a homoscedasticity. So always remember that whenever we are talking about any linear regression algorithm, you are applying the algorithms on the particular data set, and linear regression algorithm assumes that these 4 properties will be there. Then only it will be able to give you a better results, give you a better predictions, which is having a very good accuracy, very good and lower value of the error function or the value of MSE or MAE. So all these important properties you have to take care of. Now I hope that now you will be able to get a clear idea about what are the assumptions that we have in linear regression. In the upcoming session, we will talk about further important stuffs with respect to the linear regression algorithm. So stay tuned and I'll see you all very soon in the upcoming videos. Bye bye everyone and see ya.